Today we're going to learn about MediatR pipeline behaviors. Specifically, we're going to create a behavior which will validate our MediatR requests before they arrive to their corresponding handlers. To do this validation, we're going to use the FluentValidation library. If you aren't familiar with FluentValidation, then make sure to check out my video about it so you can follow along. Hi everyone, Amichai here. I do have a quick disclaimer. So even though I'm a Microsoft employee and what we're talking about are Microsoft technologies, I'm not talking on behalf of Microsoft. These are my personal opinions. What we have at the moment in our application is we have the register and login endpoints that take the incoming request and convert it to the corresponding command or query. Then we use MediatR to send the command or query to their corresponding handler, and the actual handlers sit over here in the application layer, right? So in the application layer, we have our commands and queries. At the moment, all we have is the register command and command handler and the login query and the login query handler. Okay, now one of my favorite features in the MediatR package is the ability to create pipeline behaviors. If you aren't familiar with pipeline behaviors, then all it is similar to what we have in our program CS, where our request goes through a pipeline of middlewares before it reaches our endpoints. Then also when we send a request using the MediatR, then we can have it go through a pipeline of behaviors before it reaches the actual handler. Okay, so let's see what this looks like. So I'm going to collapse the API project, and over here in the application layer, I'm going to create a new folder inside the common folder. Let's call it behaviors. And inside here, let's create our validation behavior. Okay, so just to get started with behaviors, let's say we want to write a pipeline behavior which will surround the register command. So for now, let's call this class validate register command behavior. And for this to be invoked for the register command, then yes, we need to do something similar to what GitHub Copilot is suggesting. Let's just add some stuff that we need to include. And over here, we want this to be error or authentication result. So what we have over here is because we want to write a behavior that will be invoked for the register command, then we need to implement the I pipeline behavior, which receives two types. The first type is the MediatR request we want to surround, and the second one is the response. And then over here, let's get rid of this and let it generate the correct method. And let's wrap it so it's visible. Okay, so what we have over here is we have the request, which we can use to investigate, manipulate, or log before we call this delegate, which will eventually invoke our handler. And whatever this delegate returns, then we can use again to manipulate as we wish. Right, so just to get familiar with this, then over here, we can get a result from awaiting the delegate. Let's add here async. Then over here, we can return our result. And now whatever logic we have over here will be invoked before the handler. And whatever we have over here will be executed after the handler. Right, so let's put a breakpoint over here, and in our register command handler. Okay, now if we run the application and we try to hit our breakpoint, we won't hit it yet because we need to wire some stuff together. So back in our dependency injection file, let's register this behavior. So the way this works is we want to add it as scoped, and let's see what it's suggesting. Yes, this seems right. Let's just put this on new lines so it's visible. Let's include what we need to include. Great, so basically what happens, and we might look at this later in this video, is that before MediatR invokes our handler, it wraps it in whoever implements the I pipeline behavior where the types correspond to the type of the request that it's now executing. And in our case, it's us. So let's run our application, make a request and see if we hit our breakpoint. Great, let's make our register request. First, let's attach the debugger, so F5, and let's select our application. The debuggers are attached. Let's send a request. And simple as that. So before our handler was invoked, we arrive over here at our custom behavior, we continue, we arrive at our handler, and if we continue again, then we arrive at our behavior again, and if we continue, then we get the response, same thing like before. Okay, so now that we have some stuff wired together and we're a bit more familiar with behaviors, let's think what we actually want to do. Okay, so we learned about fluent validation and we got familiar with how we can validate our objects. So let's see how this fits in with our clean architecture structured solution. First of all, let's add fluent validation to our project. So .NET add to the application layer, the package fluent validation. Great, now let's go ahead and create our validator. So because we're using MediatR to split our application layer logic into features, right? So we have each feature sitting in its own folder, then it's very convenient to simply come over here and add our RegisterCommand validator. And as we're already familiar, so what we have over here is public class RegisterCommand validator, which needs to implement the abstract validator. Yes, where over here we specify the type that we want to validate. In our case, it's the register command. So yes, let's just include what we need to include. Great, for now, let's leave it as is. So basically we want all our properties not to be empty. Then what we need to do is in our dependency injection to register it. So what we want to do is we want to say services.add scoped, and over here we want to say that validator of the register command, yes, is the register command validator, like so. But because we don't want to manually specify each one of our validators, then like we're already familiar, let's add the FluentValidation.ASP.NET Core package. So .NET add to the application layer, the package FluentValidation.ASP.NET Core. Great, now that we have that, we can replace this entire thing with add validators from assembly, and over here, let's give it the current executing assembly. So we can do assembly dot get executing assembly. Great, so now that we have this defined and wired up, back in our validate register command behavior, we can go ahead and use it. So private read only, yes, let's just include what we need to include and inject it. Okay, now that we have our validator, then we can validate our register command request. So we can say the validation result is yes, exactly. Let's just get rid of some of the junk over here. Right, so we have our validation result, and now we want to branch out depending on what we have over here. So if there were no validation errors, then we simply want to invoke our handler. But if it's invalid, then over here we have a list of validation failures. We want to convert them to a list of errors from the error or library and return them instead. So over here, let's say if the validation result is valid, then we can simply call our handler. Otherwise, let's create our errors. So this will be almost, let's say validation result dot errors. And over here, let's select, right? So each one of our errors is a validation failure, and we want to convert it to a validation failure from the error or library. So what we can do is we can say error dot, and over here we can use the validation static factory method. So we can say validation, and over here we can pass it the validation failure dot property name and validation failure. Let's see what it's suggesting. Yes, error message. Let's list it. And let's just wrap this so it's visible. Great, now each time you find yourself selecting and then listing, you can simply replace this entire thing with convert all, which does more or less the same thing. Lastly, we want to return our list of errors from over here, and that's it. Great, I want to put a breakpoint over here, send invalid request, and see that this behaves as we expect. So let's run the application, connect the debugger, send our register request. Let's change this to be something invalid. Send the request. We arrive at our behavior. We expect this to be invalid. So yes, it's false like we expect. Great. Over here, we're converting the validation failures to errors. So like we expect, we have here our 2 validation failures with descriptive error messages. Great. If we continue, then we get our error response. Now this isn't exactly what we want, so we'll be fixing this in a minute. But first, what I want to do, let me just stop the application, is I want this to be generic. So currently it's running only for the register command, but obviously we want this to run for all of our mediator requests. So what we can do is as following. First of all, let's change the name to validation behavior. Okay, now what we actually want to have over here is we want to say that this will run for any T request or T response, where the T request is a mediator request and the T response is whatever this request returns. So for that, let's add these generic parameters here as well. So T request, T response, and here let's add our constraints. So yes, right, this iRequest interface comes from the mediator package, and we also want to add a constraint on the response that it must be an error or response. So for that, let's say where T response is an I error or. Okay, now this isn't recognized because it's only available in the latest version of error or. So for that, let's update our package. All we need to do is .NET add to the domain project where this package is referenced, the package error or. This will check if there's a newer version. If there is, then it'll update to that version. Let's run NuGet restore. Great, now that we have that, let's update our handle method. So we aren't returning this anymore. We're returning the T response. And same goes for our delegate. Over here, we aren't just getting the register command, but we're getting the T request. Over here in the constructor, then we aren't requesting this specific validator, but we're requesting the validator for the T request that we received, both here and here. Now in our solution, we're always going to have 0 or 1 validators for each one of our requests. So let's make this nullable, since we won't always have a value over here. Okay, now if in your solution you have multiple validators for each one of your requests, then of course that here you can request all of your validators, and over here you can iterate through your validators and invoke all of them. Great, then over here we can say if exactly we don't have a validator, then we can simply continue. So we're getting an error over here because the compiler doesn't know that there's an implicit converter from a list of errors to the error or object. And unfortunately, there's no way around this other than doing some magic. The easiest way is to simply write over here, dynamic. This in runtime will check if there's a way to turn this list of errors to the error or object. If there is, then great. If not, then it'll throw a runtime exception. Generally, you don't want to use a dynamic keyword. It's dangerous exactly because of this. But if in your project, like in our project, you know that you'll always be arriving over here with a list of errors that you can convert to the error or object, and you know it will always be an error or object because of the constraint that we put on the response type, then personally, I think that it's completely fine to use it in such a scenario. If something really exceptional happens and for some reason this throws a runtime error, then luckily we still have over here our global error handling solution. From here, we'll get an exception that will have our entire stack trace. We'll be able to investigate it. And because we aren't working with exceptions in our system, we shouldn't have any exceptions thrown in our system. Any exception that's thrown is something that we care about. So we can easily monitor such an exceptional behavior and investigate why it happened. I want to throw a shout out to Gareth that showed me this approach. I really like it. It actually comes out much cleaner than the reflection approach. If you still prefer to use reflection and not use the dynamic keyword, then simply go to the README of the error or library, and you'll see an example of how you can use reflection to achieve the same behavior. Great, now that we have this defined, back in our dependency injection of the application layer, let's register it generically. So instead of using this add scope method, we'll use a different extension method, which receives the 2 types as arguments. This takes advantage of the generic open types feature. The same way you can request an ilogger of type T for any T without you having to explicitly register it. So the way this looks is as following. So we want to register. Yep. Yes, this seems right. Let's just wrap it. But still, it'll only be executed if it matches these rules that we defined over here. Okay, now that we have this, let's remove the previous registration. Great, so now that we have everything defined and wired up, let's run our application and attach the debugger. Let's make our register request. So great, we hit our breakpoint. I actually want to put a breakpoint over here as well for the next request. Then great, we get our error. Don't worry, we'll fix this in a few minutes. If we send valid details, then we expect the validation result to be valid and great. We invoke our handler like we expect. Okay, now if we send the login request, so remember we don't have a validator for the login query. Okay, so we make a request and we get a failure. Let's see what the failure is. Okay, and we see that we can't find a validator for the login query, and that's because I think I forgot to say that this equals null. Yes. So over here, even though we specified this as nullable, if the service provider cannot provide the iValidator of type login query, then it'll throw an exception. If we want it to be optional, then we need to set it explicitly as so. Let's stop the application and run it again. Attaching the debugger, making the login request. Great, we hit our breakpoint. We expect the validator to be null, so we simply invoke the login query handler. Let's continue, and great, we get the response from our query handler. Now I want us to fix the error response. So basically what we have back in the authentication controller is we send the register request, and over here we get a list of validation errors, right? Then because we have a list of errors, then we're calling our own problem implementation in the API controller class. So going to the implementation here, we can see that we simply look at the first error and we return, in our case, 400 and the description of the first error. But this isn't what we want to do when we have only validation errors. So what we actually want to do is as following. Let's say if all the errors have the type validation, then what we want to do is we want to return a validation problem. Okay, now similar, let me stop the application and close the terminal. Similar to the problem method that comes from the controller base, which returns a standard error response using the problem detail specification, there is another method called validation problem, which also comes from the controller base. And one of its overloads is you supply it a model state dictionary and it returns a meaningful error response to the client. So for that, let's take our list of errors and create a model state dictionary from it. So let's say model state dictionary equals, yes, a new model state dictionary. Then over here, what we want to do is almost, let's accept this, wrap the lines. What we want to say is that the key is the error code and the value is the description, right? So over here, we're simply iterating over all the errors and we're adding the corresponding model state dictionary entry to the dictionary. Now that we have this, we can simply return it from over here. Okay, let's run the application and make sure that we get the response as we expect. Making the register request. Let's make this invalid again. Send the request. And over here, we get the standard validation problem response, which, as you can see, gives us the status code 400. We get our validation failure error message. We get here the problem JSON content type. And over here, we have all the errors that occurred, where we have our property name and a list of all the failures that have to do with this property. Let's go back to our API controller and let's make it a bit better. Right, so this is starting to look a bit cluttered. What we'll do is let's take this entire thing and extract it to a method. Let's call this validation problem. Right, so now what we have is a method that knows how to take the list of errors and return the standard validation problem response. Okay, similarly, let's take this logic, extract it to a method. Let's call it problem. Right, so now we have a method that knows how to take a single error and return the problem response. Let's change the name here to error. Okay, and finally, before we start any of our logic, let's say that if there are no errors, then simply return a problem. Otherwise, if all the errors are validation errors, we want to return a validation problem. Okay, now of course you can have here whatever logic that you want. So each error can also have its custom numeric type. This is an integer, so you can define in your system, for example, a domain error is 23, and then you can check over here if all your errors are domain errors. Then over here you can have your custom logic. And that's it for now. Let's just inline this temporary variable. Great, so we added our validation behavior and we added our RegisterCommand validator. Now that we have this generic validation behavior and we wired stuff together in the dependency injection, from now on, every time we want to add a validator, it's as simple as going to the request that we want to validate, creating our validator, and that's it. Now we can be certain that in the login query handler, we'll only receive mediator requests that have been validated. Okay, now something you might be asking yourself is why we're only checking that the properties aren't empty both here and in the RegisterCommand validator. That's because I want us to get familiar with some domain-driven design principles before we talk about application layer validations versus domain layer validations. What goes in which layer? Should you have duplicate rules in your application layer and in your domain layer? That's a very interesting topic, but I want us to first be familiar with some of the terminology so that everyone watching these videos can follow along. Okay, the last thing I want us to do as part of this video is to look at how the behaviors are actually implemented inside the mediator package, just because I think it's a cool implementation and it might be nice for you to be familiar with it as well. Great, so as you can see, we have here the mediator library open in Visual Studio Code. And what I want us to do is over here, look at the mediator implementation, specifically at the send method. So when we call mediator.send, this over here is the method that is invoked. Over here, we have our request, and we can see that this is the logic that is more interesting for us. Okay, but for us to be able to investigate it, then let's try running one of the tests so we have actual data that we can look at. So over here in the test, let's choose a test that has some pipeline behaviors. Okay, so there's a nice test here, which I think can be good to demonstrate what we want to demonstrate. So we can see we have here two pipeline behaviors, an outer behavior and an inner behavior. Then we're sending a ping request and we're expecting the response message to be ping pong. And from the test, we can see that we expect the outer behavior to be invoked, then the inner behavior, and then the handler. So let's debug this test. And we hit our breakpoint. So as we expect over here in the request, we have our ping request with the message ping. The T response is pong. Then if we continue, then we can see that over here, the request type is ping. Okay, stepping over this, if we step into this handle method, then as we would expect, all the pipeline behaviors that correspond to the request and the response are being fetched from the service provider. And over here, there's a nice trick, which I think could be interesting to look into. So for that, let's stop the test and let's make this a bit more readable. So first of all, let's say pipeline behaviors is this thing. Then let's say request handler delegate equals pipeline behaviors dot reverse dot this thing. And finally, let's return the response that's returned from invoking the request handler delegate. Okay, let's wrap this so it's visible. Okay, so debugging the test again. Then we arrive at our send method. Okay, we continue to the handle method. Then over here, we retrieve all of our pipelines. In our case, we have the outer and the inner in the order that we registered them. Okay, now let's look at the request handler delegate, what this is and how it actually works. But for that, let's make some more room. Okay, so first I want us to get familiar with this handler function. So going to the end of the line, we can see that all we have over here is the actual invocation of the handler that corresponds to the given request. So we can imagine that when we invoke this handler, then it actually invokes the handler. And this handler is the seed for the aggregate method. So if you aren't familiar with the aggregate method, or specifically with this overload, then let's understand how this works. Okay, so again, we have here the outer and the inner. We reverse the order. So now the first pipeline is the inner pipeline. And over here, we're passing a function that when we call it, it'll invoke our actual handler. Okay, now the way the aggregate method works is, and let's look at it per iteration. So in the first iteration, this next argument will simply be the handler, and the pipeline will be the first pipeline. So the first pipeline is the inner pipeline. Okay, so looking at what we have over here, then we can see that we're invoking the pipeline and we're passing it the actual handler. Okay, so this makes sense. If we only had one pipeline, then it makes sense. Now we have the pipeline invoking the actual handler. I want you to notice that over here, we aren't actually invoking anything, but we're defining here a new function. This is a function that when you invoke it, then it does what we say, right? So if we only had one pipeline, then over here, it would be invoked, and then it would invoke the pipeline and invoke the handler. Okay, so this is the first iteration. Okay, now each iteration, what we're doing is we're creating an object from this type again, which is now used as the next argument. Okay, so for this to make sense, let's split the screen. Great, so I split the screen and I open the definition of this request handler delegate. And as you can see, all it is a delegate that when you call it, it returns a task of T-response. Right, now if we look again at this thing over here, then that's exactly what we're doing over here. We're defining a function that when you call it, right, it'll invoke the pipeline, then it'll invoke the actual handler, which will return a task of T-response. So again, we're creating this object. And now in the next iteration, we have over here the inner pipeline invoking the handler, but again, it's only the function definition. And over here, we have the outer pipeline. And same thing like before, this next is now the inner and the handler. And you can imagine how in each iteration, the next pipeline in the row wraps the previous pipelines, and eventually it invokes our handler. Right, so if you're curious how the mediator pipeline behaviors actually work behind the scenes, then this is how it's implemented. I really liked this implementation and the concise syntax, so I thought it'd be something interesting to demonstrate along the way. Let me know if you found this interesting. So that's it for this video. I really hope you enjoyed it, and I'll see you in the next one.
Oh my god. Oh my god. Oh my god. Oh my god. Oh my god.